Welcome to video clip 2.5, in which we discuss start events and end events. So the interaction of a business process with its environment is represented by events. So what is an event? Events are happenings of the real world that have a business meaning and that do not take time. So that's important to stress that in contrast to activities that need time to execute, events do not take time. Events are just happenings of the real world that have a business meaning and do not take time. The start event or start event models the start of a business process, and an end event models process completion with an outcome. So we have here in this process model that we have been looking at for quite a while already, we have a start event, and that is called claim received. So claim received is a happening, an event of the real world that has a business meaning. Because after the claim is received, I need to start a new business process instance that reacts to the receiving of the claim. So a start event models the start of a business process, and an end event models process completion with an outcome. So we have here two end events. One is claim approved and one is claim rejected. And here we have also events, and these two events signal the end of the business process instance, and also they are labeled with the outcome. So two different outcomes are possible here. One is claim approved and one is claim rejected. In our application scenario, we have a similar situation that the process waits to receive an order. And after receiving the order is fulfilled and the process terminates successfully. Or if the order cannot be fulfilled, the process terminates unsuccessfully and the order is cancelled. All right, so here we have a representation of this, a model representation of the text describing the process. And here we have, similar to the claim, when the claim received, the order is received. The order received is again an event, an happening of the real world that has impact, that has an effect on the process. And we have two end events, that is the order cancelled or order fulfilled. These are also events of the real world that have that have a business value, have a business meaning, so to speak. All right. If we look now at the start event and at the end events, we can see that both have some kind of a different character regarding event creation. So what do we mean by that? When a process is about to be started, it reacts on the occurrence of an event in the environment. So order received is not something that the process did by itself. So that is a happening of the real world that is relevant for the process, yes, but the process did not do that, but the process reacts to that. Regarding the end events, it's a bit different, since here the event is created during the process execution. So actively the process triggers an event, order cancelled, or an event, order fulfilled. So that's a difference, because in the first situation with the start event, the event is caught by the process catches, so to speak, this event and reacts to that. And related to the end events, the process, we say the process throws an event. So either the order cancelled event is thrown, or the order fulfilled event is thrown by this business process. So an event can be caught. In this case, the event happens in the environment and its occurrence has an impact on a process instance. Or an event can be thrown, in which case the event is created by the process instance itself. And again, a process or the start events of the process we see here are the catching events. So this event needs to be caught by the process, and these two events are thrown. Either of them is thrown by each process instance. bpm_n has a number of event types, or two event types we've already seen in the previous example. That is a start event and that is the end event. Start events cause the start of a new process instance, and end events signal the termination of a process instance. Start events are always of catching nature, and end events are always of throwing nature. In addition, there are so-called intermediate events. Well, intermediate events happen after start events, after the start of the process and before the end of the process. Therefore, they are intermediate events, and they can be of catching and of throwing nature. So intermediate events can be caught or thrown during a process instance. Events itself or themselves do not take time, happenings of the real world, but a process might have to wait for an intermediate catching event to occur. We'll see that in the example soon. So intermediate event we take from this slide are catching and throwing, and in the next video we dive in a bit more into intermediate events. In addition to these event types, start, intermediate, end events, BPMN supports event kinds. Event kinds are similar to the task types, where we said a task type can be user task, service task, or message task, for instance. And these BPM event kinds are similar in the sense that the kind of event can be represented in the model using markers of the events. So, for instance, we can express, well, BPM defines event kinds that characterize the nature of the event. For instance, a timer has expired, an error has occurred, a message was received. And these event kinds can be combined with event types, but not all combinations are allowed. We'll briefly look into this, but we cannot be complete in this related to the BPMN, because the BPMN has a very rich set of event kinds and event types, and also their relationship is defined properly in the standard. Each event kind has a symbol, and here we have the following symbol. So there is the timer intermediate event. So the symbol is this clock symbol that we see here. There's an arrow event, in this case an arrow end event. The arrow is represented by the symbol that you see here. An envelope signals a message event, similar to the task, to the message task type. The same label or the same marker is used. So this is for instance, the message start event. And sometimes I'm not interested in the nature of the event, or I don't care about it from the modeling perspective. It's not important to express which kind of event actually is expected there. In this case, we can use just a blank circle for an event, and it is called a non-event in the standard, but we can also say it's a blank event, in this case a blank start event. Modeling guideline related to events is, well, events do not consume time. Event labels should reflect that, and or labels of event should be used in the noun verb participle style. So what do we mean by this? Events are observed changes of the state of a system, the process environment, or the process itself. They must not be used to model activities. So we cannot use events to model activities or things that take time. To emphasize the occurrence of an event, label events using the noun verb participle style, for instance, order received. Order received, noun verb in participle. There's an exception, again, an exception to this modeling guideline, and that is timer events. So I can write the timer event every Monday at 10 a.m. That is a typical label of a start timer event, where I start a process every Monday at 10 a.m. and then I just tell the date and time when new process instances need to be created. Also related to events, we need to use a consistent vocabulary. So order received. So order is not just a word, but order should then also be reflected not only in the events, but also in the activities when I check the order or enter order details or something. We have seen this in our examples already. So looking at start events and event kinds, A start event triggers the creation of a new process instance and starts its execution. There are different types or different kinds of start events. So blank start events are used if a process is started manually or if the kind of start event is not relevant for the modeling purpose. Timer start events allow the definition of a particular date, time, or recurring dates for the start of the process. So every Monday at 10 a.m. would be an example of a timer start event. And we also often see message start events that indicate the start of a process instance upon reception of a message. And we had that in our example in the order, in our order example, the event is order received, so it's a message event. Once an order is received, I create a new process instance. There's quite some discussion about a number of start events, a number of end events, and I have a modeling guideline also related to this. So each business process model should have exactly one start event. That makes a process instantiation, so the question when is a process created, easy to understand, because once the start event occurs, process is instantiated. Sometimes we see that there might be several start events that are required, but these shall always be alternative. When I need several start events to create a process, a number of issues are related to that. We cannot go much into the detail in the context of this course. But it's a good idea to start every business process with one start event. Still, I have an example that shows you a situation when multiple start events are there, and we said that if you use them, they shall be alternative. So I'll briefly sketch a process with 3 start events, so I can receive an order by a fax message, for instance. Then I first need to type the order details from the fax message into my system using some form. I can also receive it by email. By email I also need to prepare that, but I can just copy that, so that's a different model as a different activity here. Then I have this join node in which I said, well, I can either receive it by fax, receive it by email, or I can receive it by a web form, and assume I need to do some semantic checks when I receive it by fax or by email. And I can also receive it by web form. If I receive it by web form, I do not need to do these checks, and I don't need to enter this, so I can start the process in this way. So this is an example, and sometimes we see this when I have different options, different options to start a process, maybe order received by fax message, by email message, or by a web form, and then you have alternative start events, and that will be the structure, at least, of a business process with alternative start events. Use a distinct end event for each possible outcome of the process. So different results of a process have often different business meanings and shall therefore be distinguished by different end events. We see in this example in our order case, where we have one end event, so the order might be cancelled at the end of the day, or the order might be fulfilled. These are happenings, these are events that have a business meaning, and we like to represent the 2 different possible outcomes explicitly in the model. And I think in many cases that's very important to model the important property of a process is its possible outcomes. It's important that the end events are exclusive, that we don't have many end events that could happen at the same time, because that would also hinder understanding, would make understanding a bit harder, and therefore it's a good idea to define end events as being exclusive. And in this case also it is completely clear when a process terminates, and a process terminates if one end event has been signaled, or if one end event occurs, to be more precise. And this completes video clip 2.5, in which we discussed start events and end events. We introduced events and said that processes interact with its environment, with the environment by events. That events do not take time, have a business meaning. We looked at start events and end events. We talked about events that are thrown by the process, and we talked about events that are caught by the process. We looked at event kinds, message events, timer events, also the non-event or the blanco event. And finally, we concluded this video clip by looking at modeling guidelines related to start events and end events.